So this video is an introduction to the next series of operations that we're going to talk about, which is exponents and the associated broad term for it, which is powers. But before we can get into exponents and powers, we need to back up a little bit further, and we need to go back and think about what is multiplication. So I'm going to ask you to pause the video here and sort of brainstorm some ideas. How did you remember hearing multiplication when you were in lower elementary school? What sorts of ways did you talk about it? How did you describe it? Just go ahead and pause the video, take 30 seconds to a minute, write down some ideas that you have, and then come back when you are ready to move on. So there are lots of different ways that people have talked about multiplication and that folks probably remember learning about multiplication when they were younger. One of them is through what's called an array, where you would have, for example, 3 rows of 4, or rather 3 columns of 4, 4 rows of 3 x's, and you count out the total number of things in the array, and you find out that's the same as 3 times 4, because that's the number of columns times rows, or also 4 times 3, because that's the number of rows times columns. That's one way you might remember talking about multiplication. Another way of talking about multiplication, which is the one that we're going to use that you might have seen, is the idea of repeated addition. That is, multiplication represents addition that is done several times. So 4 times 5 would be the same as 5 times 5 times 5, or sorry, 5 plus 5 plus 5 plus 5. That is 5 added to itself 4 times. Alternatively, it could also mean 4 plus 4 plus 4 plus 4 plus 4, or 4 added to itself 5 times. And the fact that these two additions end up at the same sum when you do it backwards or forwards, in terms of what number is added to itself how many times, is really a pretty fundamental thing when it comes to operations. The fact that we can do it either way is really kind of incredible. And so if we look at the example of 3 times 12, that's either 3 added to itself 12 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 12 added to itself 3 times, which is much easier to write, thankfully, 12 plus 12 plus 12. And then we create this idea called multiplication so that we don't have to write out these big, long sentences anymore. We can just say 3 times 12 being 36, and we know what that means. And the natural question that comes next is, are there other sorts of repeated operations? Can we repeat multiplication, for example, and say that something is going to be multiplied by itself a certain number of times? And it turns out that we actually can. What if we wanted to multiply 4 by itself 3 times and represent that that was something that we were interested in doing, rather than having to say 4 times 4 times 4? Could we do it in another way? And we can, and we do it in the other way by using what are called exponents and powers. Now, I'm going to ask you to listen to this for a second, and then I'm going to give you an indication to pause the video and write down some definitions here. A power, which represents repeated multiplication, is made up of 2 parts. The first, called the base, is a number that's written normally, and that is the number that is being multiplied. A second number, the exponent, is the number of times that the base is multiplied, and that is raised above the first number in something called superscript. If it's written above a number, it's called superscript. If it's written below a number and it's small, it's called subscript. So I'm going to ask you to write down a few of the things that are here, and pause the video. You're going to write down the fact that powers represent repeated multiplication. You're going to write down pretty much everything that you see here in the yellow box that has to do with powers and exponents. So go ahead, pause the video, write out everything here, including the example, the fact that it's raised above or written normally, the definitions of the parts, everything that you see, and come back when you're ready to move on. So altogether then, these things create what is called a power. The exponent and the base together create powers. Now, we know when we add, we call the operation addition. When we subtract, we call it subtraction, multiply, multiplication, etc. This particular operation, raising something to powers, is actually properly called exponentiation. after the fact that we are using exponents. I'm not going to ask you to memorize that, but if you do hear me use that in class, calling it exponentiation, that is the actual technical term for it in math. So let's take a look at what this looks like. We said that the base and the exponent had particular meanings. The base was the number being multiplied, so it's 4 multiplied by itself a number of times, and the exponent tells you how many times it's going to happen. So 4 raised to the third power, or 4 to the third, is 4 multiplied by itself 3 times, or 4 times 4 times 4. Now, it's very important that we don't confuse the meanings of the base and the exponents. Although addition is commutative, and multiplication is commutative, exponentiation, or raising things to powers, may or may not be commutative, and that's one of the things that we're actually going to investigate once we get into class. So let's take a quick look at some example problems before I ask you to do some on your own. Here are 2 examples of powers. The first one, 5 to the second power, means 5 multiplied by itself 2 times, or 25. And 4 raised to the fourth power is 4 multiplied by itself 4 times, which altogether is 256. So base multiplied by itself the number of times in the power. So now go ahead, pause the video, write down these powers, describe what it means, and evaluate or determine the final product for each of the following powers. Go ahead, pause your video, work on these powers, and come back when you are ready to move on. So for number 1, that is 5 to the third power, or 5 times 5 times 5. That product is 125. 3 to the fifth power for number 2 is 3 times 3 times 3 times 3 times 3. And that product is 243. When we expand 2 to the seventh for number 3, that's what it means to write out the power as the multiplication it represents. 4, 5, 6, 7. We end up with 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 128. And then finally, 1 to the 15th power is 1 multiplied by itself 15 times. I'm not going to write the entire thing here, but 1 times itself, no matter how many times we do it, is just 1. So now that you've heard the bell there in the video, we have one last thing for you to think about and write down some brainstorming ideas for before you finish your homework for class tomorrow, and that is the question, is exponentiation commutative? A big important question when it comes to powers. And to rephrase that question, in case you've forgotten what the idea behind a commutative operation is do we get the same product when we switch the base and exponent? We know that 2 plus 3 is the same as 3 plus 2. We know that 2 times 3 is the same as 3 times 2. But is 2 to the third power, for example, the same as 3 to the second power? Do we get the same product? First, before you actually go through and do some examples, I want you to think about, do you think it should be true? What's your instinct on it? And then whenever you come up with that idea and can explain in your notebook why it is that you think that's going on, go ahead and choose a few examples and see if your theory is actually true. So again, just brainstorm some ideas for, is exponentiation commutative? Can we switch the base and exponent and get the same product? And why or why not?